So now we start our question number 3. Find dy by dx of the following parametric functions. Parametric functions, as we discussed in chapter number 1, if a function y is equal to f of x is in the form x is equal to f of t and y is equal to f of t, then such a function is called parametric functions. And in simple words we can say that x is depending upon a parameter t and y is also depending upon parameter t, then such a equation or such a function will become a parametric functions. And now we have to differentiate such type of functions in which x and y are depending upon another parameter t or parameter theta, and by using our chain rule we will form dy by dx. As I say that y is equal to f of x is not given in this case. The given functions is in the form x is equal to f of t and y is equal to f of t, or x is equal to f of theta or y is equal to f of theta. Then by differentiating both of these functions separately, then by using chain rule we will form our required dy by dx. Now we will explain this with the help of these questions. So now x is equal to theta plus 1 over theta and y is equal to theta plus 1. As we discussed here, x is dependent upon t or y is also depending upon t, and in this particular question x is a function of theta and y is also a function of theta. Now by differentiating both of these functions we will ultimately find dy by dx by using our chain rule. So start our question. Let x is equal to theta plus theta raised to the power minus 1, which is in the form of 1 over theta actually. So differentiating with respect to theta, as x is the function of theta, so we have to calculate change in x with respect to theta. So dx by d theta will become d by d theta of theta and d by d theta of theta raised to the power minus 1. By using our sum theorem, applying derivative on both of these two functions separately, now derivative of theta will become 1 and derivative of theta raised to the power minus 1 by using our power rule, that is actually minus 1 theta raised to the power minus 1 minus 1, which will become minus 2. So that can be written as 1 minus 1 over theta square. By shifting it into the denominator, that will become a positive power. So now by taking LCM, that will become theta square minus 1 over theta square. So this is actually our dx by d theta. Now we differentiate y is equal to theta plus 1 with respect to theta. So now y is equal to theta plus 1. Again, as we can see that y is a function of theta, so we have to calculate the change in y with respect to theta. So differentiate with respect to theta, dy by d theta is equal to d by d theta of theta and d by d theta on 1. So derivative of theta will become 1 and derivative of 1, as due to the constant function, that is the derivative of 1 will become 0. So we have dy by d theta is equal to 1. Now as we calculated dy by d theta and dx by d theta from here, so by using our chain rule, dx by d theta and dy by d theta, then we have to form dy by dx. So by using our chain rule, dy by dx is equal to dy by d theta and d theta by dx. By putting the values of dy by d theta, which is 1, and d theta by dx is theta square theta square minus 1. Actually, we have dx by d theta. We have here dx by d theta. In our previous slide, that was actually theta square minus 1 divided by theta square. But by using our chain rule, we have here we have to form dy by dx. So by using chain rule, that is actually dy by d theta and d theta by dx, which is just a reciprocal of this one, dx by d theta. So now putting up the values of d theta by dx, which is actually reciprocal of this one. Now this will become theta square over theta square minus 1. Now we put this value in d theta by dx, so the result will become 1 into theta square over theta square minus 1, that is actually dy by dx is equal to theta square divided by theta square minus 1. Now our next part is x is equal to a into 1 minus t square divided by 1 plus t square, and y is equal to 2bt divided by 1 plus t square. Again, we can see that this one is actually a parametric function. X is depending upon t and y is also depending upon a parameter t. We have to calculate actually dy by dx, but from here we can calculate the change in x with respect to t. So we will get here dx by dt, and from here we will calculate dy by dt. Then by using chain rule of both of these two derivatives, we will form our required dy by dx. Now we start our differentiating process. Solution: let x is equal to a into 1 minus t square divided by 1 plus t square. Differentiate with respect to t. Dx by dt is equal to, a is the constant term, so will come out from derivative, and derivative will apply only on variable portion, and this is actually in the form of quotient or fx over gx type. So we will use our quotient theorem here. A will be as it is, and by applying quotient theorem here, first we take the square of the denominator 1 plus t square whole square, and 1 plus t square will be as it is, and derivative will apply on numerator, which is 1 minus t square, minus 1 minus t square, which is actually numerator, will be as it is, and denominator will apply on denominator, which is 1 plus t square. So now 1 plus t square will be as it is, and derivative of 1 minus t square, derivative will apply both of these functions. 1 is the constant term, so derivative will become 0, and derivative of t square will become minus 2 into t by using our power rule. Minus 1 minus t square will be as it is, and derivative of 1 plus t square, derivative of 1 will be 0, and derivative of t square will be 2 into t. So now we can take 2 into t as a common factor from both of these two terms. So 2t is the common factor. We have minus 1 and this minus t square, and this is a common factor, so we have minus 1 and minus into minus will be plus t square. This minus t square plus t square will be cancelled out, and we have 2at minus 1 and minus 1 will become minus 2, and divided by 1 plus t square whole square, and our finally dx by dt is minus 4at divided by 1 plus t square whole square. So this is actually dx by dt. Now we start differentiating of y is equal to 2 into bt divided by 1 plus t square. So differentiate with respect to t. Dy by dt on left hand side and is equal to 2b is the constant term. Derivative will apply only on the variable portion, which is t divided by 1 plus t square. Again using quotient theorem, this 1 plus t square whole square and 1 plus t square will be as it is. Derivative will apply on numerator, which is t, minus t will be as it is, and derivative will apply on 1 plus t square. So applying derivative, 1 plus t square will be as it is, and derivative of t will be 1, minus this t will be as it is, and derivative of 1 plus t square. 1 is the constant term, so derivative will be 0, and t square will become 2 into t by applying derivative. So now simplifying this portion, now that will become 2b into 1 plus t square minus 2 into t square, and that is 2b 1 t square minus 2t square will become minus t square, and this denominator will be as it is 1 plus t square whole square. So now we have calculated our dy by dt and dx by dt separately, and by using our chain rule we will form our dy by ds. So by using chain rule, dy by dx is equal to dy by dt and dt by dx. Again we are actually converting dx by dt and dt by dx by using our chain rule. So by putting this value, dy by dt is 2b into 1 minus t square 1 plus t square whole square into dt by dx, that is actually the reciprocal of dx by dt, which we calculated in our previous slide, that is 1 plus t square whole square divided by minus 4at. This 1 plus t square whole square will be cancelled out, and we have this minus 2 2's are 4, so we have b into 1 minus t square divided by 2at. So that is actually our required dy by dx, which is minus b into 1 minus t square divided by 2at.